Section 6.1, Greatest Common Factor and Factoring by Grouping. This should be a review, so we're going to go through it as a review process. Well, factoring is the process of writing a polynomial as the product, meaning multiplication, of two or more polynomials. And we know that 5x times 2x plus 3 would equal 10x squared plus 15x by distributing. So factoring reverses this process. The first thing we want to be able to do is find the greatest common factor. Well, the definition of the greatest common factor is the coefficient in the degree that evenly divides all terms. For example, 20x squared, we want to write the prime factorization. Well, 20 is 4 times 5 and 4 is 2 times 2. So if I look at 20x squared, it's 2 times 5 times x times x. 15x, well, 15 is 3 times 5 times x. So to be the greatest common factor, it has to be in common in both. So my GCF would be 5x, and that's it. I'm going to let you do number 2, and I'll tell you what the GCF is. The GCF should be 5y. So see if you can get 5y from the GCF there. So factoring a monomial from a polynomial, the first thing we want to do is determine the greatest common factor for all terms, express each term as a product of the greatest common factor, and then use the distributed property in reverse to factor out the greatest common factor. So look at number 3, 3y minus 3. This is 3 times y minus 3 is just 1 times 3. So what is the greatest common factor of each of those terms is just 3. So I'll factor out the 3 and I'm left with y minus 1. The great thing about greatest common factor from factoring is you can check it. 3 times y is 3y and 3 times negative 1 is negative 3. So I know that I factored it correctly. So on number 4, we have 9y squared, or sorry, 9y to the 4th. Well, that would be 3 times 4y's, plus 27 is 3 times 9, but 9 is 3 times 3. And we have to do the prime factorizations. And then we're going to be multiplying y 6 times. So let's see what we have in common. We have 1 3 and another 3, so that would make 9. We have 4 y's here, and 1, 2, 3, 4 y's there. So my greatest common factor is 9y to the 4th. So if you're looking at your variables, take the one with the smallest exponent because that's as many that's in common. So 9y to the 4th. Parentheses. Since everything was taken out from the first term, you know you still have a 1 there because you have to multiply 9y to the 4th times 1 to get 9y to the 4th. Plus, what's left over here is the 3 and y squared. So you're going to hopefully get to the point where you start seeing what the GCF is and not having to write the prime factorizations. So I'm going to circle number 5 for you to try, but I'll give you the answer. It's 5x times x squared minus 4x plus 2. Now just so you know, what I did was I rearranged in descending order before I started. So I put that in descending order and then factored out my GCF. On number 6, 11x squared is 11 factor. So that in a sense means we cannot factor that. So we're just left with 11x squared minus 23. Sorry, that's a little messy. So 11x squared minus 23 cannot be factored because the greatest common factor is just 1. So on number 7, if we look at 32, 24, and 16, again, once you do these a little bit more, you can hopefully see what's in common without having to write the prime factorization. But between the 32, 24, and a 16, there's an 8. You have x to the 3rd, x to the 3rd, and x to the 2nd, so only x to the 2nd can come out. You have y squared, y, and y, so only a y can come out. So from here, we'd be left with a 4xy minus 3x minus 2. Now just so you know, the book shows it a little bit different. In the book, what they try and do, for example, we start over with 3y minus 3, and they say the GCF is 3. So what they want you to do is take the first term and divide by 3, and the second term and divide by 3, with this 3 still out in front. And so that just gives you y minus 1. So they show it a little bit different. So if you like that way, feel free to do so. You're just dividing every term by the greatest common factor and simplifying. That is if you're just doing a monomial. Now let's factor by 4 terms. Well, with 4 terms, what's the first thing we want to do? We want to group the terms that have a common monomial. So you kind of want to see which ones have something that's in common and group them and factor, in a sense, group 2 and then group the other 2. There usually will be 2 groups. Factor out the greatest monomial factor from each group, and then factor out the remaining, and most likely it will be a binomial factor if one exists. So for example, on number 8, some of the factoring is already done for you. What I want you to realize is this is considered a GCF. It's in common in both of them. So you have to take out the x plus 2, called the binomial. And what's left in the first term is this x, this one right here, and what's left in the second term is a minus 4. So the answer to number 8 would be x plus 2 in parentheses times x minus 4 in parentheses. Now same thing on number 9, they've already done some of the factoring for you. And so you can see that you have a binomial that's in common. So we're going to take out an x plus y. Now some students just want to write 3x and say that's it. But it can't be it because you're missing the minus sign, and if everything comes out, remember what's really in front is a 1. So you still need to have that 1 left. So now let's do it all together. Number 10 has x squared plus 2x plus 4 plus 8. So we have 4 terms, and we have 4 terms we factor by grouping. I'd like to see you do it this way. Group the first 2 terms, and then group the second 2 terms. Don't use parentheses yet because that kind of gets a little bit confusing with the way that you're supposed to write it. So with the first 2 terms, an x is in common, so we'll put out an x and we're left with x plus 2. Now remember, this sign has to stay in between. So don't forget, you do still have a plus sign in between. And now what's in common with the next 2 terms? You have a 4x plus 8, so there's a 4 in common, and you're left with x plus 2. So just like with the problems 8 and 9, now you have a common binomial. So we'll pull out the common binomial, which is x plus 2, and we're left with the x plus 4. Now some students say, can I write x plus 4 first and then x plus 2? Sure, it's multiplication, and multiplication is commutative, so you certainly could. So I'm going to circle number 11 for you to try on your own. I'll give you the answer. It is x minus 2 times x squared plus 5. So let's look at number 12, and I'm going to add a couple more problems on here as well. So we're going to group the first 2 terms, leave the plus sign in between, group the second 2 terms. And we're going to be left with y plus 5. Plus, don't forget that sign in between. What's in common between a 9y and a 45 is a 9, and we're left with y plus 5. If you know your multiplication well, factoring is much easier. So work on your multiplication if that is where you struggle right now. So now we have a common binomial of y plus 5, and so we're going to write what's left from each term, which is x plus 9. Again, you can multiply this out and you should get back what you started with. Might be in a different order, but you should be able to get back what you started. Y times x is xy, y times 9 is 9y, 5 times x is 5x, and 5 times 9 is 45. So go ahead and add a number 13, which is mn plus np minus 3m minus 3p. Because so far everyone we had has had a plus sign in between the groups. What happens if there's a minus sign in between the groups? So we're going to group the first 2 terms, keep the minus sign in between, group the second 2 terms. So with the first 2 terms, there's just an n in common, so we're left with m plus p. Now be very careful. There is a minus sign in between the groups. What's in common with the next group is a 3. But we're not left with m minus p, we're left with m plus p. If you factor out a negative times a negative is a positive. So you have to have a positive there. So negative 3 times m is negative 3m. Negative 3 times a positive p is negative 3p. If you would have a negative here, you would not get back what you started with. Also, these would not be the same. And in 116, those better be the same. Now that they're the same, we'll take out the m plus p. And in parentheses, what's left is the n minus 3. And again, you could write n minus 3 and then n plus p if you'd like. So I'm going to give you one more to try. Number 14, you're going to have a 15st squared minus a 5t squared minus a 30st plus 10t. I'm giving you another one to try with that minus sign in between. I'm going to give you the answer. Don't forget, from the very beginning, there is something in common in all of them. So you can actually have a 5t GCF, and then once you do your factor by grouping, you'll have a t minus 2 and a 3s minus 1. So first thing I would do is factor out a GCF, which is a 5t from all 4 terms. If I factor out a 5t from here, I'm left with 3s t. 5t from here would be a minus t. 5t from here would be a minus 6s, and a 5t from here would be a plus 2. Now do your factor by grouping. Group those 2 terms, minus sign in between, and those 2 terms. Leave the 5t out in front, and you should get that final answer.